I just want to start by building on something that Dave mentioned earlier about what our current capability is in terms of science productivity on Hubble, where we are now and where we expect to be at the end of this mission. Assuming that we accomplish everything that we set out to do on this mission, once the science instruments are fully commissioned and they're up and operating and producing science data, the amount of science data produced by the observatory in the first 6 months will be equal to the total amount of data produced by Hubble in its first 8 years of operation from when it was launched through servicing mission 2. So that kind of gives you a little bit of a feel for the spectacular increase in productivity from where we are today to where we expect to be after SM4. And this underscores the importance of SM4 to the astronomy community and Hubble in particular. SM4 is unique in several respects. It's our last planned servicing mission to Hubble. We'll be repairing 2 science instruments in place, something we've never done before. We'll be installing a soft capture mechanism on the aft bulkhead of Hubble that will facilitate a future mission to Hubble to safely deorbit it. And the other thing is we've never gone 7 years without a servicing mission, so we have 7 years of accumulated maintenance work to do. So if you can imagine if you had a car and you were driving it every day for 7 years and never took it into the shop, you'd have quite a list of things to do on it. So very briefly here, the goals for SM4 are to upgrade our science capability by installing the 2 new science instruments, perform the needed maintenance, and to repair the 2 science instruments that Dave mentioned. The first graphic that I want to show identifies the specific mission tasks for this mission in priority order. And the prioritization is important in a couple of respects. It helps to guide us in terms of putting the mission together, but we don't allow the priorities to overdrive the importance of packing as much into the mission as we can so that we can get the absolute best productivity from the servicing mission. But the priorities will become extremely important in the event that we have a shortened mission. If for some reason we have to give up part of an EVA day or all of an EVA day and can't do it, we've gone to great lengths to pre-plan the mission so that we can know instantly where we're going to be headed next. We've also done planning with regard to the acceptance testing and functional testing of the hardware that's installed. If something doesn't work out, doesn't pass the tests, at some point we may decide to reinstall the older piece of hardware if something like that were to happen. So on this mission, because it is the last one and because of the great amount of work that we have planned for it, this mission has been pre-planned to a much greater extent than any of the prior servicing missions. So we, as you can see from that list, we've got 6 gyroscopes we're going to put on board, the wide field camera 3, the science instrument command and data handling unit, the cosmic origin spectrograph, all 6 batteries. Those batteries now, some of them are almost 20 years old, although they've only been on orbit about 18 years. We will then do our first science instrument repair, the fine guidance sensor change out, a second instrument repair, and then the new outer blanket layers or nobles, which are insulation repairs on several of the electronics bays. The science instrument repairs are something that we have never done before on Hubble, and these instruments were never designed to be repaired on orbit, so this has posed a great challenge to our technical team and to the astronaut team. The repair is very complex, very time-consuming, and so the outcome of these repairs is much less certain than simply exchanging an ORU or science instrument, one of the black boxes on Hubble, because we don't have the benefit of working on the hardware here on the ground and testing it out as thoroughly. We've done our very best on this, and we have high hopes that all of this is going to work out as planned, but it's important to understand that these are not the same type of work that's being done in the other areas on the observatory. When the Science Instrument Command and Data Handling Unit A side failed back last September, we immediately switched over to the B side and continued producing science. But of course now Hubble is zero fault tolerant to not producing any science if we lose the B side. So changing the SIC and DH out is very important for this mission. And you may recall, those of you that were following the mission last fall, that it was already pretty full in terms of activities for the astronauts. So the next graphic here shows our plan for the servicing mission now. Basically, the way we were able to accommodate the SIC and DH was the battery installation that we had planned. I think it's on Bay 3. We had planned to do it on EVA Day 1. We moved that down to EVA Day 5. And what got displaced by the battery installation on EVA Day 5 was part 2 of the ACS repair. The original plan was to have ACS repair broken up into 2 parts. That was the only way that we could make it work. Unfortunately, there was a considerable amount of overhead associated with breaking it up like that, because we have to go back into the work site twice, and so that wastes a lot of time. So our goal all along had always been to try to do ACS repair in a single day on EVA Day 3. And when the SIC and DH failed, we redoubled our efforts to try to make the ACS task more efficient and to bring the time down. So there was a lot of hard work done by our HST development team and by our astronaut EVA team, in particular Dr. John Grunsfeld. And I'm delighted to report that they made huge progress, and so we think we can get this job done in one EVA day, but it's going to take more than the standard 6.5 hours that we normally plan for each day. We'll need probably an extra 30 to 40 minutes. And so a real-time decision will be made by the flight director, Tony Sacacci, during the mission. If things are going nominally with the orbiter and with the crew, and we've had good results on EVA Day 1 and 2, and the COS installation goes well on EVA Day 3, then there's a high probability that we'll get the approval to go ahead and complete the ACS repair on EVA Day 3. If not, it still gives us a leg up in the event of certain contingencies that could happen downstream. And so it's still a good strategy to do it the way we have it planned. So in summary, SM4 is a very packed mission. There's not much margin for error. We'll need flawless execution from our astronaut team, and we'll also need flawless performance from all of our hardware, the orbiter and the HST hardware. But we have done extensive testing, extensive training, and we're highly confident that we're going to have another successful mission like the ones we've had before.